Hello, welcome to Astronautics for Exploit. This is Dr. Ayeshola Ogundele. Lunar-based space solar power, a route to the harvest of terawatts of solar power on the moon. The focus points of my presentation are as follows: sustainable lunar exploration, solar cells fire moon resources, lunar solar power array concept, and lunar solar power generation and transmission to the Earth. Galileo Galilei, the first selenologist and astrobiologist, to base his findings on observations rather than speculation, laid the foundation for the modern astronomy. Space probes, telescopes, and several observations of the solar system and the Milky Way. Galileo's first telescopic discovery in the year 1609 that the moon was not perfect sphere and that it contains mountains, peats, and other features like the Earth, in contrary to the thought of the scientists as of that time that the moon was a smooth sphere, revolutionized our understanding of the universe. Based on his observations of the moon and various resources, such as solar power, oxygen, and metals that are found by research and probes to be abundant on the moon, humans have created interest in exploring the moon for the benefit of humankind. A reliable and sustainable energy technology for the generation and storage of electric energy is essential for the actualization of sustainable moon exploration and permanent settlement on the lunar surface. Based on the abundant solar energy on the moon, researchers are proposing to generate electricity from the moon. This is in preparation of various future manned moon missions, in which on the moon astronauts will need to have access to electric power to be able to live and work on the lunar surface. Also, the idea is to transmit solar power from the moon to the Earth for humans' benefits. Various solar energy generation and transmission demonstrations are being executed and planned. For example, the photovoltaic investigation on the lunar surface program, a program to demonstrate light to electricity power conversion devices for future missions, is a solar power experiment that uses state-of-the-art solar cells like those on the satellites and next-generation space solar cell technologies. This program is also designed to test the feasibility and viability of the solar cells on the lunar environment. Research findings show that there is an ongoing plan to begin construction of a lunar solar power base as early as 2035. Sustainable lunar exploration. Lunar exploration of the moon for the benefit of humankind, is helping humans to understand the origin and earliest evolution of the Earth-Moon system. Exploring the moon is helping to enhance humans' knowledge of the inner solar system, the near Earth, and cosmic environment throughout most of the solar system history. A concept of collecting solar power up in orbit, where sunlight is up to 11 times more intense, and then beaming it down to the ground for use, is shown in this picture. Sustainable lunar exploration. Presently, various government space agencies and private space companies are mapping out strategies and developing different missions that will aid the return of humans to the moon. Various moon missions being put forward are journeying towards laying foundation for achieving sustainable human presence on the moon. The picture here shows artist rendering of the gateway in lunar orbit with the Orion spacecraft on approach. First mission to the Mars. The idea behind a sustained lunar operation is to gain experiences and develop technologies that will support a historic first human mission to the Mars. As humans are aiming to push the space exploration boundaries, effective techniques will be obtained by conducting scientific exploration synergistically with crew and robotic explorers. Illustration of the manufacturing on the moon is shown in this picture. Solar cells fire lunar resources. Research findings show that the Earth's moon, the Earth's only natural satellite, contains substantial natural resources which could be exploited for the benefit of humankind. Potential lunar resources are volatiles and minerals and geologic structures such as lava tubes that together might enable lunar habitation. The picture here shows artist's impression of a moon-based concept. Lunar resources, in situ resource utilization. The information gained about lunar resources from orbit and sample return missions have greatly enhanced humans' understanding of the potential for in situ resource utilization at the moon. The use of resources on the moon has been propelled to provide a means of reducing the cost and risk of lunar exploration and beyond. The picture here shows a picture of moon where astronauts are exploring the moon surface. Examples of lunar resources: solar power, nuclear power, oxygen, water, hydrogen, and metals such as iron, aluminum, titanium, carbon, rare earth elements, helium-3, carbon and nitrogen, dust and regolith for construction. Lunar materials could facilitate continued and sustainable moon exploration. Scientific and economic activity in the vicinity of both Earth and Moon, which is the cislunar space, or they could be imported to the Earth, where they will contribute directly to the global economy. Artist's depiction of the float lunar railway system to provide reliable, autonomous, and efficient payload transport on the Moon is shown in this picture. Solar cells fire lunar resources. Information gained about lunar resources from orbit and sample return missions have greatly enhanced humans' understanding of the potential for in situ resource at the moon. Presently, various space agencies and companies are scouting for lunar resources from lunar orbit and using landers and rovers. Illustration of a moon factory is shown in this picture. Daylight on the moon lasts approximately 2 weeks, followed by approximately 2 weeks of night, while both lunar poles are illuminated almost constantly. The lunar South Pole has a region with crater rims exposed to near constant solar illumination, and the interior of the craters are permanently shaded from sunlight and retain significant amounts of water ice in their interior. The picture here shows images of the distribution of surface ice at the moon's South Pole and North Pole as fused by Moon Mineralogy Mapper Spectrometer. Solar cells from Lunar Resources Processing Facility. Research findings show that by placing a lunar resource processing facility near the lunar South Pole, solar-generated electrical power will allow for nearly constant operation close to water ice sources. Photograph of regolith advanced survey systems operations digging a trench in simulated lunar soil is shown in this picture. Consideration is ongoing on the prospect of fabricating solar cells on the lunar soil by a medium-sized rover with the capabilities for heating the regolith, evaporation of the appropriate semiconductor materials for the solar cell structure directly on the regolith substrate, and deposition of metallic contacts and interconnects to finish off a complete solar cell array directly on the ground. This picture shows NASA's exploration campaign in low Earth orbit, in orbit around the moon and on its surface, and at destinations far beyond, including Mars. The fragmented surface layer on the moon is planned to be excavated, transported to a processing facility, that is dump trucks, Its target ingredients extracted by eating and the products such as volatiles, water, oxygen or metals transported to a site for further processing or to use to manufacture a useful item such as solar cells, tools and a host of others. The picture here shows lunar gateway concept. Lunar solar power arrays. A solar power array is a collection of multiple solar panels that generate electricity as a system. The most important part of a solar panel system is the solar array. It holds all of the panels in the system, which is where sunlight is collected and converted into electricity. The picture here shows artist's impression of a moon-based concept. Different concepts of solar arrays and its deployment on the moon are being proposed. An artist's solar power array concept in the picture shown here shows the deployment of solar arrays which convert sunlight into electricity on an initial lunar camp of the future. A concept of the development of solar arrays and its deployment is shown in this picture. Flexible solar power array. In the concept, immediately after landing, two large flexible solar arrays will be rolled out window shade fashioned from the lander. According to the concept, one panel will be tilted towards the eastern horizon, while the other faces west. This allows the array to produce power during the entire 2-week stay without tracking the sun. The picture here shows lunar resources extractor on the lunar surface. Moon-based preparation. The solar power arrays will be designed to provide power while the astronauts scout the area and prepare the base for living and working. Later, the astronauts would set up a larger sun tracking array to provide higher power levels. The picture here shows illustration of a future lunar base, which could be made more simpler by using a 3D printer to build it from local moon materials. The moon buggy. For exploration, surveying, and lunar prospecting, the astronauts are planned to drive around in a battery-powered moon buggy. The buggy will have its own small solar array, which tops off the battery charge whenever the rover is parked. The picture here shows multi-dome lunar base being constructed based on the 3D printing concept. Lunar solar power generation and transmission to the Earth. Presently, some researchers are working on developing solar power on the moon. There is an ongoing plan to begin construction of a lunar solar power base as early as 2035. Research shows that lunar solar power arrays will receive higher energy density from sunlight than we get through Earth's atmosphere, avoid weather, and could beam energy to any part of the Earth facing the moon. The picture here shows the Peregrine lander that holds 9 lunar experiments. Lunar solar power generation, microwave beaming. The key to lunar-based solar on Earth is microwave transmission. Energy from the sun can be converted into microwaves in the same way radar beams are being generated. Efforts are ongoing to demonstrate the feasibility of space-based solar power as an advanced energy system. The picture here shows a concept of collecting solar power up in orbit. In the 1970s, research was conducted on how best to utilize lunar materials, and it was discovered that all the materials needed for manufacturing photovoltaic cells were present in lunar rocks and dust. The generated solar power on the moon can be wirelessly beamed through the Earth in a safe and controlled way as either a microwave or laser beam. The picture here shows solar power for lunar living. For more information, contact Astronautics for Exploit. You've been watching and listening to Lunar-Based Space Solar Power, a route to the harvest of terawatts of solar power on the moon, presented by Dr. Anyashola Ogundele, with the focus points: sustainable lunar exploration, solar cells, fire moon resources, lunar solar power array concept, and lunar solar power generation and transmission to the Earth. Thank you.